Today I am going to start class 10 first chapter named real numbers. Okay, now real number. Real number is a combination of rational number and irrational number. Rational number and irrational numbers. Okay. Okay. Now rational number means you learned in class 9 if a number decimal expansion is terminating. Okay. For example, 2.35. Here decimal expansion is terminating. Or if a number decimal expansion is non-terminating but repeating, that is 2.3333 and so on, then it is called a rational number. And irrational number means if a number decimal expansion is non-terminating and non-repeating. Okay, non-terminating, non-repeating. Here 2 1, again 2 1 1, next 2 1 1, but not repeating. Okay, so it is called an irrational number. So real number meaning rational and irrational together called real number. Okay. Next topic is Euclid's division lemma. Given any positive integers a and b, there exist unique integers q and r satisfying a equal bq plus r, where 0 is less than equal r is less than b. Okay. Now its meaning: if we divide any number by 2, then see 2 5 are 10, that means remainder is 0. Again, if we divide a different number 11 by 5, then 2 5 are 10, remainder is 1. That means if we divide any number by 2, then the remainders are 0 or 1. You can divide more numbers, 12, that means if 2 6 are 12, remainder becomes 0. Again, 2 6, if you divide 13, 2 6 are 12, 1 remainder. Okay, that means 0 or 1. Okay, next. So now b, this b means see a equal twice q plus r. Just I divided by 2. So a equal twice q plus r, where 0 is less than equal r is less than b means 2. That means r equal 0 and 1. Okay, 0 means see 0 less than equal r, that means r values is greater than 0 or equal 0 but less than 2, that means 0 and 1. Similarly, if we divide any number by 3, then remainders will be 0, 1 or 2, that means less than 3. Okay. Now exercise 1.1, question number 1, Roman number 1. Question is, find the HCF of 135 and 225 by Euclid division algorithm. Okay, that is we need to find the HCF of 135 and 225 by Euclid division algorithm. Okay, but you can't apply class 6 7 means lower class HCF method. Okay, for class 10 use only one formula, that is Euclid division algorithm. Okay, now see the solution. Here 225 is greater than 135. So 225 write in the left side and 135 write in the right side. Next, you divide 225 by 135. Do according to long division process. 225. How many times? One time. Then 135. See, 5 minus 5 0. 12 minus 3 9. Means 135 one time and remainder become 90. Next, now 135 transfer to left side and 90 write instead of 135 plus. Again you divide 135 by 90. See, long division, 91 is 90 and 45 is remainder. So 90 how many times? One time and remainder is 45. Again 90 transfer to left side and 45 right at 90 place. Now divide 90 and 45. 45 to the 90. Remainder 0. 45 how many times? 2 times, and remainder is 0. See, we got remainder 0. If remainder 0, that is called last line. Okay. Now we got the HCF is 45. Therefore, the HCF of 135 and 225 is 45. Clear? Okay. Similarly, you can solve question number 1, Roman number 2 and 3. Now proceed to question number 2. Question number 2 is, so that any positive odd integers is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. Okay, see the solution, right? According to Euclid's division lemma, write that Euclid's lemma A equal BQ plus R, where 0 is less than equal R is less than B. It's called Euclid division lemma. Okay, A equal BQ plus R, where 0 is less than equal R is less than B. Okay, now question is, so that any positive odd integers is of the form 6q plus 1, 6q plus 3 or 6q plus 5. So at B place you write 6. Okay, see, if B equals 6, then A equal 6q plus R. B means 6. Then 0 is less than equal R is less than B means 6. Then that means R equal, see, R values are greater than 0, equal or greater than 0 but less than 6. That means 0, 1, 2, 3, 4, 5. Okay, 0, 1, 2, 3, 4 or 5 means less than 6. Next, if remainder 0, keep 0, then A equal, see, 6q plus 0 means meaningless. Okay, now see, if a number is divisible by 6, means a factor is 6, then we can say it is an even number, which is an even. Clear? Next, if R equal 1, then A equal 6q plus R value 1 plus 1. See, if we divide any number by 6 and remainder is 1, then it is called an odd number, which is an odd. Okay. Similarly, plot R equal 2, then A equal 6q plus 2. If we divide any number by 6 and remainder is 2, then it is called an even number, which is an even. If R equal 3, then A equal 6q plus 3. If we divide any number by 6 and the remainder is 3, then it is called an odd number, and odd. Again, if we divide any number by 6 and remainder is 4, then A equals 6q plus 4, which is an even number. Again, if we divide any number by 5, then A equals 6q plus 5, then an odd number. Okay, now see, when we divide any number by 6 and remainders are 1, 3, 5, 1, then odd number, 3 odd number, and 5 odd numbers. Okay, this is an odd number, and odd number. Okay, these are the answers. So you can write the sentence from the question, right? This one sentence. Therefore, write from this one to last step. Therefore, any positive, and write this one step. Any positive odd integers is of the form 6 cube plus 1 or 6 cube plus 3 or 6 cube plus 5. Okay, now question number 3. See the question number 3. Question number 3 is an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay, now here number of member is 616 and number of columns is 32, means the number of 32 members in a column. Now question is how many columns can you form? Okay, then find the HCF of 616 and 32. See here 616 is greater than 32. So find the HCF according to Euclid division algorithm. Okay, see here 616 right in the left side, next 32 right in the right side, and divide 616 by 32. See 32 how many times? 616 one time, then 32, 11 minus 2 9, 5 minus 3 2, 6, 296. Next how many times? 32 18 9 times, 9 to the 18, 1, 9 3 27 plus 8 28, 288, and 16 minus 8 8 0. So 19 times and remainder is 8. Next 32 transfer to left side, here 32 and 8 right at 32 place. Next divide 32 by 8. 8 how many times? We know 8 4 is 32 and remainder is 0. Line completed because we got the remainder is 0. Therefore HCF of 616 and 32 is 8. 8 is the answer. So how many columns we can form? Therefore number of column is 8. Okay, now question number 4. Question number 4 is use Euclid's division lemma to show that the square of any positive odd integers, is either of the form trisame or trisame plus 1. According to question number 2, same process, write that Euclid's division lemma. According to Euclid's division lemma, A equal BQ plus R, where 0 is less than equal R is less than B. Okay, now see the B value. B value is given in the question. See trisame and trisame plus 1. So the B value is 3. If B equal 3, then A equal thrice q plus R. A equal thrice q plus R, where 0 is less than equal R is less than 3. Okay, that means R equal 0, 1 or 2. That means less than 3. Now we need to plot. At first R equal 0, next R equal 1, and next R equal 2. But see here one square word is given. Okay, so we need to square the both side. Okay, first one, if R equal 0, then A equal, plot here, thrice q plus 0 means thrice q. Okay, but according to question we need to square. So square both side. A square equal thrice q whole square. Then 3 square value 9 and q square. But question 1 in the form trisame, not 9q square. So write as 3 into thrice q square. See 3 is a 9 q square. Same meaning. Okay, then 3 this thrice q square means you can write m within bracket right, where m equal thrice q square any integer. Okay, this one is first step. A square equal thrice m. Okay, that means we got in the form thrice m. Okay, next point. Now we will plot r equal 1. Next we will square it. After that again we will plot r equal 2. Now see, if r equal 1, then if r equal 1, then this one is the last next step. Okay, next step. See, then a equal thrice q plus 1. Next, both side whole square it. Then a square equal thrice q plus 1 whole square. Now see, a plus b whole square formula satisfying. So apply it. A square means 3 is a 9, q square plus twice ab, 2 is a 6, 6q, and 1 square below 1. But see, they want in the form thrice m or thrice m plus 1, not 9q square plus 6q plus 1. So from the first two terms, take 3 common. Then thrice q square plus twice q and outside 1. So bracket part meaning m and plus 1, where m equal thrice q square plus twice q and integer, means where m is an integer. Okay, we got thrice m plus 1, but you can't avoid 2. So do the next step for r equal 2. See, if r equal 2, then a equal thrice q plus 2 whole square. Sorry, a plus thrice q plus 2. Then both side square it. So thrice q plus 2 whole square. Now open the bracket according to a plus b whole square formula. Then 3 square 9, 9q square plus 2 to the 4, 4 is a 12, 12q and 2 to the 4. See, they don't want plus 4, they want only plus 1 or plus 0. No value means plus 0. So we can write as 9q square plus 12q plus 3 plus 1. Okay, now from the first 3 terms, first, second and third, take 3 common. Thrice q square plus 4q plus 1 outside 1. So the bracket part is m plus 1. Done? Okay. So m equal, where m equal thrice q square plus 4q plus 1 any integer. Okay. Now we got the answers. In the first step we got thrice m. In the second step, if r equal 2, r equal 1, then we got thrice m plus 1. Again in the third step we got thrice m plus 1. So you can write from this one. Therefore the square of, from this part, therefore the square of any positive integer is either of the form thrice q or thrice q plus m. Right? At last, this one sentence. Okay, done. Next, proceed to question number 5, exercise 1.1. Last question, number 5. Use Euclid division lemma to show that the cube of, now cube of any positive integer is either of the form 9m or here 9m plus 1 or 9m plus 8. Okay, recall question number 4. If b value is, or b value was 3, then remainders were 0, 1 or 2. Means 0 means 1 step, 1 means second step, 2 means 3 steps. Okay, but if b value is 9, then how many steps are there? See, 0, 1, 2, 3, 4, 5, 6, 7, 8, Many steps are there. Again, cube required, so it will be long or not. So I'll give you one shortcut process. See, here 9 given. Listen, if a number is divisible by 9, then that number must be divisible by 3. Okay, for example, 9 2s are 18, 3 6 are 18. That means 18 is divisible by 9. Again, 18 is divisible by 3. Similarly, 54, 9 6 are 54. Again, 3 18s are 54. That means if a number is divisible by 9, then that number must be divisible by 3. So instead of 9, we can plot 3 at b value. But at last we want as 9m or 9m plus 1 or 9m plus 8 form. Okay? At first plot b equal 3. Write the first step according to Euclid's division lemma. A equal bq plus r, where 0 is less than equal r is less than b. If b equal 3, then a equal thrice q plus r, where 0 is less than equal r is less than 3. Now 3. That means remainders are 0, 1 or 2. So now we need to solve only 3 steps. If 9, then how many steps required? Imagine 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 steps required or not? But if 3, then we need to solve only 3 steps. Okay? So first step. If r equals 0, then a equal thrice q, means plus 0, thrice q plus 0 or thrice q, same meaning. But according to question, what they want? Cube. So cube both side. Thrice q whole cube. Okay? Now expand it. 3 cube value 27 cube. But see the form, only 9m or 9m plus 1 or 9m plus 8. So 9 into thrice q cube. See, 9 3s are 27 q cube. Same answer. Then write 9 thrice q cube meaning m, where m equal thrice q cube, any integer, where m is any integer. Okay? Next. Now next step for r equal 1. Again, third step for r equal 2. Okay? Now we will continue. See. If r equal 2, sorry, at first r equal 1, then a equal thrice q plus 1, thrice q plus r value 1. So both side whole cube it, a cube thrice q plus 1 whole cube. Now which one formula satisfying? See, a plus b whole cube formula. Okay, expand it according to a plus b whole cube formula. A plus b whole cube formula is a cube plus 3 a square into b plus 3a b square plus b cube. A cube plus 3a square into b plus 3a b square plus b cube. Okay, a plus b whole cube formula. Now expand it. 3 cube 27 q cube, 3 square 9, 9 3s are 27 q square plus 3 3s are 9, 9 cube, 1 square not required, 1 cube value 1. Let's see the forms. 9m plus 1 or 9m plus 8. So from the first 3 terms take 9 common. Then thrice q cube, 9 3s are 27 q plus 1. Then 9 bracket meaning, bracket part means always 1, oh sorry, m. Okay, then see where m equal thrice q plus thrice q square plus q comma any integer. Okay, we got the second form 9m plus 1 for r equal 1. Next step for r equal 2. See, if r equal 2, then a equal thrice q plus 2. Then both side q be whole cube thrice q plus 2 whole cube. Okay, now see again a plus b whole cube formula. A plus b whole cube is a cube plus 3 a square into b value 2 plus thrice a b square plus b cube. Okay, a cube plus 3 a square b plus 3 a b square plus b cube. Now open the bracket, 3 cube value 27 q cube. Next 3 is a 9, 9 is a 27, 2 is a 54 q square plus 3 is a 9, 9 4 is a 36 q and 2 cube value 8. Now from the first term, second term and third term take 9 common. 9 common, then thrice q cube, 6 q square, 4 q plus 8. Okay, then bracket part means always m, 9m plus m bracket where m equal thrice q cube, 6 q square plus 4q. See the last form 9m plus 8. Okay, we got the all steps. So at last right, therefore from here the cube of any positive integers is either of the form 9m, 9m plus 1 or 9m plus 8. You write this one. Okay, clear.